Welcome to the AKS Troubleshooting series. In this show, our goal is to empower you. Whether you're a developer, a cluster admin, platform engineer, or just like solving problems, to confidently tackle real-world challenges found in Azure Kubernetes Service. My name is Maya Singh, and I am a product manager working on AKS observability. Each episode, we'll dive into common issues faced in production environments, and our expert guests will break down how to tackle them. In today's episode, we are going to be learning about node auto provisioning. And with that, I'd love to introduce you to our guest today, Wilson Darko.
Thanks, Maya. How's it going, everyone? My name is Wilson Darko. I am a product manager in the Azure Kubernetes Services team, and I focus on compute scaling and just kind of improving and optimizing that experience. Great to be here.
Awesome. Yeah, thank you for joining us, Wilson. We're really looking forward to learning from you and learning about node auto provisioning as well. Just to start off, why is it important for customers to understand the fundamentals of scaling, how it works, and eventually we'll talk about node auto provisioning in detail?
Yeah, so in terms of the general experience, right, let's talk about the happy path. For most users, we could say all, the goal is to just be able to, uh, deploy your workloads and get them to operate as you need them to. And in that, if you need kind of more demand in certain instances, that it should scale reliably. And really, it's something that you want to not have to worry about. You can kind of set it and forget it. What ends up happening there is you now have to think of a balancing act between a couple areas. You want proper performance, of course. You're trying to make sure that this cost matches the exact need or as close to the need as possible, but never too much where you just have kind of excess spend for compute. And then kind of the technical complexity or operational effort to manage all of these things. Again, you want to focus on your workloads operating as you need them to. So you're not trying to spend too much time in the weeds on trying to figure out Kubernetes issues. Where do scaling issues kind of come into all of this? And some customers have probably experienced this. You might deal with a zonal allocation error or some other kind of capacity shortcoming or maybe gaps in quota, for example. And now your workloads are stuck. You're not able to get them to work as you need them to. And again, this stuff is not fun for someone to be experiencing. So the better you can understand how to optimize your scaling experience in AKS with different tools that we'll talk through, the more time you can kind of spend on what matters.
Absolutely. That makes a lot of sense. So, this environment of scaling is
Mhm.
multifaceted, and customers have a lot of different options when it comes to scaling. They can use VMs, VMSS, NAP, which we'll talk about. Can you give us the rundown of sort of that landscape and
Yeah.
what customers need to consider?
Yeah, so the traditional experience in AKS has been based off of virtual machine scale sets, as we call it, or VMSS. This is a way to be able to scale up the same VM size, ideally very quickly and relative to your needs. Right. Since we've kind of had scale sets in production, we've kind of built out a few other experiences just to address some of those capacity needs that customers have and to increase the ability to be flexible. So with VMSS or scale sets, you can essentially scale up or down the same size VM within a node pool. If you have capacity errors, then you probably have to kind of navigate that a particular way. But from a flexibility standpoint, you now have the option of virtual machine node pools, which is another kind of node pool model, still in that similar structure to VMSS. But in this case, you now have the ability to update the VM size or have multiple VM sizes within that same node pool or group of nodes. So if you find that you have a capacity error in a VM node pools based node pool, because a certain size isn't available, a VM size isn't available in your region or zone, then you can just update that size to something else that is available and you should be fine, right? In this scenario, it's still very specific. You have to highlight specific VM sizes or SKUs, as we call it, and that requires you to be very detailed of what sizes you want to use exactly. Again, that's the traditional model. Where we've kind of restructured things or reimagined them, if you would, is with node auto provisioning. Node auto provisioning is based off of the open source Karpenter project. And with this experience, you have, again, all the things that you could have done with scale sets or VM node pools, but an added flexibility where you don't even need to specify exact VM sizes. In some cases, you could do that, or you could even go as broad as just family sizes, so or family series. So this would be a D series general purpose VM, or something that is compute optimized or memory optimized, or even you can kind of select the full range of, hey, I want anything in this range of VM sizes that's available that works for my workloads. And from that, node auto provisioning will then select the best compute optimized option for your workloads. So it's a more intelligent experience. I'll pause there just for some thoughts there.
Yeah, that makes a lot of sense. Thank you for sort of running us through the VMSS versus the VM node pools. And now we have this node auto provisioning experience to add even more flexibility for customers so that they can scale their workloads appropriately and hopefully not encounter the same challenges that you would if using sort of like a traditional VMSS model. We now have some more flexibility. And yeah, thank you for mentioning also that node auto provisioning is based off of the open source project Karpenter. I think some folks might be familiar with that as well. And like we as AKS really value the open source communities innovation and contributions to the community. And it's awesome we're able to bring this technology now to AKS customers as well.
Mhm.
So my next question is, when folks are considering using node auto provisioning, what are some of the best practices that they should consider when really configuring an app and going through that process?
Yeah. So I would frame it this way. So with traditional node pools, in many cases, you can just kind of um, plug and chug your workloads and not necessarily have to think through some of the Kubernetes best practices. Whereas with node auto provisioning, it can do, in many cases, as much as you need it to. So giving it guardrails to tell it specifically what you want it to do is what we strongly recommend, right? In that case, there's a couple scheduler based behaviors that you can set as a user. So I will share my screen. Um, Let me know if you can see my screen, and there we are.
Yep.
Uh, so some versions of that, essentially at your deployment spec or workload file, are
Yeah.
things like node affinities and anti-affinities, labels. These are things that you would kind of specify which nodes you want your workloads to land on, should they be
Okay.
scheduled. And we usually encourage that users set these things so that you can have a very predictable scaling experience. In addition to that, if you want resiliency across multiple availability zones, topology spread constraints is kind of the best way to set that. Some customers might, in traditional node pools, create a separate node pool per zone, for
Okay.
example. You don't have to do that with NAP. In this case, you can just kind of set your topology spread constraints and make them as strict or as flexible as you need them to be. That would be either best effort or a hard constraint, as we call it. And then from there, NAP will figure the rest out for you. So those are, from a scheduling standpoint, those would be kind of the top areas. Another consideration would be taints and tolerations. This would be a way for you to kind of, again, say very explicitly, I only want these workloads to land on these specific VMs or VM sizes.
Okay.
Um, all of these things, again, are just the different knobs that you can set to make the experience as predictable as possible. Not every user needs to be that fine grained. So we do have a default deployment spec or node pool file, if you would,
Cool.
that as soon as you turn on node auto provisioning, that default is out there, right? So you can schedule workloads off rip. That being said, if you just want to get this level of specific, these are the different buttons that you can press there at the workload level. Any questions there?
Yeah, so we could maybe talk about the topology spread for a second. So
Yeah.
that basically enables the nodes to be scheduled across different geos, or how does the topology spread work, and what should a customer take into consideration when
Yeah.
defining that?
Yeah. So what you want to accomplish with topology spread is, hey, if I want to have my workload spread out across 2 or 3 zones, so that if there's a regional outage or zonal outage for some reason, I still have workloads that are running in that case. So in this scenario, we usually see customers schedule across 3 zones
Okay.
using topology spread, which I have kind of shown on the screen here. And there's 2 different ways that you can set topology spread constraints. You can have
Okay.
hard constraints, which says, hey, under no circumstance should you be kind of unevenly spread, if you would, when scheduling. Or my priority is I just want my nodes, my pods to be available, and best effort scheduling is okay with me. That would be this field that you set in your workload or deployment spec, right? So that's just something to consider there. Yeah, I hope that kind of answers the question on topology spread.
Yeah, absolutely. So this basically is in the GitHub, and folks can look at this as an example as well. This YAML file
Yep.
itself for
Yeah.
sort of an example of what the
Yeah.
workload
So
should look like. Yeah.
Yeah, so as I mentioned, node auto provisioning is based off of the open source Karpenter project. We actually have an open source Azure Karpenter provider that kind of builds out this experience. So you can check it out. You can see the different example workloads or examples of our node pool custom resource definition files, the things that you set to be able to kind of get NAP to work the way you want it to. You can check out all of those examples. And of course, we are open source. So if you have any ideas of experiences you would like to see, you can contribute to our provider. And you might end up seeing that in the actual code base. So really exciting stuff.
Yeah, that's awesome. Okay, so this is the workload file. The next one that you wanted to talk about was around the node pools.
hmm
Okay.
So uh, interesting naming convention, but we refer to the node pool file or the custom resource definition as the way for you to essentially define the guardrails that NAP will select from, right? So I mentioned, again, these are all very configurable, so you can customize these as much as you want. But in the node pool file, you could have taints that you set up to schedule certain behavior. You can define things like the type of architecture that you would want included or you want your nodes to kind of choose from, the operating systems as well. You can define if you want spot or on demand compute. And kind of the exciting part with NAP is instead of having to specify specific SKUs only, you can still do that in NAP. You also have the option to specify just a general family as well. So again, in the scenario from a capacity standpoint that you have unavailable SKUs for one specific size in a region or zone, in this case, NAP's logic will see that that's unavailable, mark it as unavailable, and then just go down the list. So you're less likely to have stuck nodes in that scenario. So it's pretty exciting. You also have other tools like the AKS node class, which is another custom resource definition file, where if you have any Azure specific settings that you want to kind of detail, this could be for, FIPS compliant images. This could be to set any other variables that you might need to adjust. You can accomplish those in the AKS node class. So again, by default, these things are scheduled for you or deployed for you. And if you want to kind of get it more custom to your business needs, you have that option.
That's awesome. So this is all built in a very modular way, it appears, to enable these different types of specifications, whether that's the like SKU family or these very like maybe regulatory compliance type of node classes as well that allow you to like put some guardrails, kind of like you opened up with, around how the actual node selection goes, so that
For sure.
it's not just all free range, but folks know their workloads the best and can define those sort of specifications.
For sure. And for most users, the general purpose or the kind of default node pool or these definition files should work for you. So out of the box, it'll be functional. That being said, the other factor to consider with NAP is from a disruption standpoint. One of the superpowers for NAP is the ability for consolidation. What does that mean? In the scenario that your current nodes are underutilized or empty, instead of them just kind of stay active and essentially imbue cost to your system, you can now scale those down in a way that's even more fine-grained than previous auto-scaling options. So the exciting part about that is NAP will either see, hey, you have certain types of compute that's underutilized. Let's see if we can either delete those down or replace them with cheaper options. That, while very exciting, in some cases, it can almost work too well, right? So if you want to control how often that behavior is happening, you have, again, more guardrails to set that up. You can either space out, hey, I only want consolidation to happen this many seconds after the most recent version, or I only want it to happen on the weekends outside of business hours. The world's your oyster. So it's really exciting kind of flexibility that you can leverage. So
Yeah.
really, really good stuff.
Yeah, I think that's a really good call on the consolidation piece, because it's such a great cost savings tool for businesses and customers, but being thoughtful around it and putting your constraints. I like what you mentioned, like around business hours, for example. It could be a practice that the customers consider adopting for sure, based on, they know their workloads and their customers' needs the best. So great, great tip there. Awesome. This has been so great. Is there anything else that you would like to share with the audience?
I would say if you have any other kind of areas of interest, definitely check out some of our content that kind of speaks through the experience with NAP and autoscaling. This includes some of our blog posts on our AKS engineering blog. We have YouTube videos. We have plenty of docs. But if you want to even talk to agentic tools or AI to kind of learn more about this stuff, those options are there. So, and lastly, hey, contribute to our open source project. We always love to see participation there.
Awesome. Thank you so much for coming on the show, Wilson. We will provide those materials that you just mentioned to the audience in the description of this episode. And for you watching at home, please subscribe to our channel and feel free to add some comments or questions in the comments as well, and we will get back to you. So with that, thank you again, Wilson, and everyone else. We'll see you next time. Bye.
Take care.